Hello everybody. Today I want to talk about one problem, one puzzle, sort of. It's the name of the thing. It's a knight's door. An idea of knight's door. It's we have knight and we have chessboard, and we want to cover all squares in the chessboard with knight, and I want to demonstrate this thing in C++ and SDL. So I have Emacs here. Wait a sec. Looks good. I have Emacs, and let's start it. First of all, I want to make something with SDL. And actually I do not remember how to use it, but we can Google, right? SDL2 tutorial, and let me see and find some good tutorials. So let's use this thing. I don't know, I cannot find. Oh, it's YouTube video. I don't want to watch YouTube videos. SDL tutorials. Come on, looks like I need to do it by myself. So first of all, I need to initialize SDL. First of all, I need to include it. Include SDL2, SDLH. So next thing, I need to initialize it. And I want to initialize, I think actually I can initialize only video, and then I check for 0, and in case of error, I just can print out the error here. See error. It is, oops, too much. And turn -1. Compile it. So we are compiling it like this. WL to print out warnings. March native to optimize for native my CPU. This one it's for debugging, so it will generate symbols compatible with my debugger. Pthreads include symbols. C++ 14. This is not needed for me right now. Main CPP, and we are putting to temporal directory main CPPO, and then we linking it with this one is important thing. So now we can run it in debugger, night tour, and there is no errors. This one is from debugger. I need to figure out why it's happening, but for now I do not know. So next thing, I want to create window and renderer, and I want to have my current resolution. It's 1280. My video capturing resolution by 720. I want to have option OpenGL, and it's going to create the renderer, window and renderer is going to be SDL renderer. First parameter actually window, so SDL window, width, height, and I think momentarily we should see the screen. So it's going to blink. Yeah, I don't know, did you see it? Yeah. Okay, so next step is run. Actually I want to clean the screen. because I enable OpenGL, I can use it. And I will use white color, and it's for transparency. Actually, it doesn't matter which one. So now I'm going to modify a projection matrix, and I'm going to set 1280 by 720. And the reason why I swap here 0 and 720, because in OpenGL axis goes in mathematical way. Y-axis goes from bottom to up, and if I swap this thing, it will go from top to bottom. And I don't care about Z, and I just put it something in between 0. So I need to include OpenGL. I don't remember exactly how to include gl.h. Sounds right. Identity. And now I can run the loop, but before running the loop, I want to run cleaning code. Destroy and SDL window, and actually I need to run SDL quit. Now I can run the loop. So inside the loop, I'll run done. So it's infinite loop, and there is a I can wait for event. There is a two calls, wait for event, and there is another one, poll event. So I think I want to use pool event. So if SDL not equal 0, I'm going to check for quit. If e type equal SDL quit, I'm going to set done to true. And here I want to clear, and after GL clear, I want to do SDL render, something like this. So SDL clear actually takes which kind of buffer. So I want to clear color buffer. So let's see how it works. Yeah, we got the white screen here. So basically it's ready, and I can try to close it. So, and it works. So now we can draw something. Can draw something test. Begin, GL lines, GL end. So I'm going to use OpenGL before 3.0. It has cleaner API, but I think it's lower for this reason. It's deprecated on most systems on Mac. I think now you can use only version 3, but fortunately on Linux I can use old OpenGL. So GL vertex ref, and we can use from 00 till 120, 1280 by 720, and hopefully we will see the line. I think I can use 2F. Yep. We don't see the line, and I think it's fine because I just need to set the color. Yeah, there is a line. So right now I think because we have checker chess table, so I want to use square 720 by 720, and here for ortho I will use 8 by 8, and I will be able to draw the checkerboard. So 0 s by 8 plus I j, and I want to draw quads, and quads are going to be I, j, I plus 1, j plus 1, and I'm going to draw quads only if I plus j is odd number, even number. We got something interesting. So JL quads. We need actually 4 vertices. It doesn't matter how I will go. Think like this, so it will make the checkerboard. Here is it. I think I will use slightly brighter black color. Let's use 7, I thinking. Okay, and for night I will use I'll use red color or green. Yeah, I'll use green. So I'll begin lines, and I'll have some global variable which will have pair, float. Let's call it Tor. Now I'm going to use C++ 11 feature, and first be second, and actually it's going to be integer. First plus 0.5, second plus 0.0. I need vector, and I have to use pair. So it's not drawing anything, and I'll put some test variables here. Tor push back make pair 0 0 and 0 1 2 3 4. Let's see. It's only one line. I have to use line stripe, line stripe. Right. Yep. So we see here green line. Hopefully it would be coded good enough. So now I can run here, find solution, something like this as the so I want to have chessboard, and it will have occupied or not. So so it's going to be Boolean, right? 8 by 8, and just call solve, right? Solve, and solve. I'm going to run in the thread. So I want to include thread. This is also C++ 11 feature. Auto my equal std thread, and I just call solve, and at the end I can just call nothing. I don't need anything else. And here, first of all, I'm going to populate chessboard. I out j from I, j equal false. So now I can run solver, right? Or I will do this thing. So I clean it up here. So now I have this thing, and I can I need to put night on one pair 0 0, and also export 0 0 equal true. Okay, now p equal to back, and then there is a list of moves. So the list of moves, it's moves list equal so 1 2, right? Then -1 2, then 1 -2, and -1 -2, right? And there is 8 moves, right? I think there is 8 moves. So also it's going to be 2, 1, negative 2, 1, 1, and negative 2, negative 1. So this is a list of moves. So I can iterate through all moves. Move. And basically what I need to do be second. I think solve has to return boolean, and if plus second plus or it's going to be out x if x less than 0 or x greater or equal than 8 or y less than 0 or y greater than 8, we skipping this move. Also if chessboard x and y occupied, so it's true, we also skipping. Otherwise we pushing it to Tor, push back, pair x and y, and also chessboard x and y equal true, and we run solve again. Solve with this situation. If solve, we just return true. If not solved, we restoring to push pop back chessboard x and y false. Also we need to protect this thing with mutex, push back and pop back. So I want to have mutex, and here I'm going to do mutex lock, mutex unlock, here is lock, mutex unlock. I'm hoping I'm right. And do I need to include mutex? Chessboard. Oh yeah, and if we went through all moves and didn't get anything, we return false. We tried everything and didn't work, right? So here also I want to protect whole loop with mutex, lock, mutex unlock. So it's not this code is not exception safe, but I don't care. Now we have solver and it's trying to solve thing, and you can see it's trying and hopefully it will get some results soon. Oh, there is no stop condition. For this reason it's not working. If door size 4, 8 by 8, turn true. Nice. Start from beginning. There is a still not working. Oh, did I compile it? Yeah, I did compile it. Still not working. Oh, this is bad. Door size 8 by 8. Let's try with some smaller checkboard like chess const int size 4, size. Okay, 4 by 4. I see nothing. What it's doing? There is only one thread. If solve, return true. Door size, return true. Let me put here breakpoint. Actually, I want breakpoint here. Delete 0, delete 1. There is only one thread. What's going on? didn't go here. I can put sleep here. What I need to include for sleep? UniSTD. Debugging. So this sleep is too slow. I want to make sleep before pushback here. Four by four doesn't have solution. It's possible, right? Let me read up Wikipedia. Zero, zero, zero. 4x4 doesn't have solution. So let's make it 5x5. I want to remove sleep. Yeah, for 5x5 we got solution. So why it's crashing here? Do I need to run join? Probably. Let me run join. Let's call it T and then T join. So here's its solution and I'm closing it. Oh, now it's, so I need to run join. Let me delete breakpoints. First of all, how to get the list of breakpoints? Remove breakpoint. Run. So this is for 5x5. Let's see for 6x6. This is for 6x6. For 7x7, there is a for 7x7, and for 8x8, I was waiting and didn't get anything. So there is a quite a nice heuristic. So you try to go to place from which one I'll have the most number of moves, and in this case I would be able to solve the knight tour. So like Wonderful, right? We move the knight, so we will always proceed to the square from which the knight will have the fewest onward moves. So we need to calculate the number of moves, like here, for example, right? There is a 2, 5, 7, 7, 7, 3, so we have to go to this place. So what I can do, I can do first iteration and have multi-map, right? So I want to have T-map, and it's going to be number of moves and index to move, so and here I will be or just move, right? Let's see, pair int. Now so I'm going here, I'm going to iterate. Let's do this one, and here I'm going to iterate. Oh, at least here I want to calculate. So let's move 2 and auto int count equals 0, auto x2, so it's going to be x1 x1, xy y, x2 is going to be 1 plus move to first, y move to second, and I'm going to run this thing. So but 2, 1, 1, and plus count. If count greater than 0. Oh, I don't, it's so for the moves list, insert std make pair count and std make pair just p, so I don't need to make pair. Multi-map, map, second, right, second first, second. Okay, let's see how it will handle 8x8 now. Boom. It didn't work. Oh, move, right? Yeah, as you see, it's handled it instantaneously. So let's do for 9. In fact, so fast we cannot see how it does this thing. So let's add something to slow it down. So it's 9 for 9 by 9. I put 1 second, but because of my algorithm of speeding up, so you will see it slightly faster. So that's it. We can play with 10 by 10 and so on, but I think you got the point. So this is the program. It's not too big. Thank you for watching, and bye.